Hello. We all know that the circumference of a circle is given by the formula 2 pi r, and the area of a circle is given by the formula pi r square, right? Children learn this in about 7th or 8th grade, and do you know why the circumference is 2 pi r? Or do you know why the area is pi r square? The why behind the area and the circumference is seldom explained when teaching. So today let's dive into this. Let's understand why the area is pi r square. Before that, I would encourage you to draw any circle with a compass so that you know its radius, and then when you know its diameter, let's say the diameter that you take is maybe 10 centimeters, and the circumference. Now, how would you calculate the circumference if you don't know this formula? You can pause and ponder for a while. A clever idea to do this is you keep a thread along the border of the circle, completely bringing it back here, and then remove the thread and straighten it out and measure it on a ruler, and that gives you the circumference of the circle. Now take that circumference and divide it by the chosen diameter and see what value you get. Because this is an experiment, we want to collect data, which means you will do this experiment for another circle with a different diameter this time, one more circle with a different diameter this time, and see what values you get. You will see that this value is almost 3.14. There will be some errors, a little bit of an error because of human measurement errors, but this is how the mathematicians previously who came up with 3.141567 know that the ratio of circumference to diameter of a circle is always constant. It is this number, this is a rounded number that is always constant, and that is the number pi, the irrational number pi, which means that circumference is diameter times pi, and diameter is 2 times radius. So circumference is 2r pi, rearranging that 2 pi r. This is why the circumference is 2 pi r. Perfect. Now let's keep going and let's try to understand why area is pi r square. Now before we go to the area of the circle, let us first understand the area of a rectangle. If we have any rectangle, let us say we have this rectangle whose length is 10, let's say 10 centimeter, and width is 1 centimeter. Perfect. Okay, let's copy this and make one more. Let's copy that and make one more. Perfect. Now, how much is the length? The length is still 10 centimeter. How much is the width? 3 centimeter. What is the meaning of area? I know you guys know that to find area you just do length times width, but why? Again, why do you do length times width? So the basic concept of area, if you have to explain to somebody who has no idea of math, so this is something that I encourage, that always when you understand a mathematical concept, understand it in such a simple way that you will be able to explain it to somebody who does not know any math. So you should understand it in a very simple layman's language. So what is area? If you take a piece of paper and keep it on your table, then that piece of paper takes up some space on the table. Maybe your water bottle next to you has a base, a circular base, a triangular base. There are fancy water bottles now. But the amount of space the base of the bottle takes up on the table is the area of the base, like it is the area of the paper, area of a rectangle if it's a rectangular paper. And for convention, when we take a simple square like this, whose side is 1 centimeter, all sides are same, then the area of this square is 1 centimeter square. This is our basic belief. From here we take up further the concept of area. So naturally, if we have two such squares, then the area is 2 centimeters square, right? So area only means you count the number of 1 centimeter by 1 centimeter squares, provided the unit of measurement you have is centimeters. So like that, if we try to count the number of squares in this blue rectangle that we have, then there are 10 squares in the first row, 10 in the second, 10 in the third, which means we are doing 10 plus 10 plus 10, and if you know the relation between addition and multiplication, then that is 10 times 3. This is the reason why we do length times width. Perfect? Okay, let's proceed. So we are comfortable with finding area of a rectangle. Okay, and now we want to find area of a circle. So whenever we do this kind of approach where we move from a straight line to a curvy line, then we try to think, okay, how can we approximate this curvy line to a straight line? So we are trying to make approximation of a circle to a rectangle, meaning we're going to try to convert a circle into a rectangle. Interesting, yeah? Let's see how that happens. Okay. Let's come back to taking some circles, and I'm going to start with a part of a circle, which is 1/8 of a circle. So there will be, how many parts will there be? Of course, 8 parts. Perfect. Let's split the circle and give these ones a tad bit of a different color, and every alternate I will give that very cute looking purple color. I usually like to keep my drawings with a nice color, because when things look pretty, you want to do them, you want to read them, you want to play with them, so why not? Perfect. Lovely. Okay, let's go ahead. Let's take this purple guy and keep him here. Remember, what we're trying to do is we're trying to convert the circle to a rectangle. Actually, it would be nice if you pause the video right now and ponder for a while on how we can do that. Perfect. Knowing that you have pondered a little bit, let's go ahead. So let me take this another purple guy and straighten him out and keep him just next to this one. Same procedure for the third purple, and same procedure for the fourth purple. Okay, I think you might have a feeling of where I'm going with this. I personally really love this approach because it's just so fascinating of how you can take a circle, split it into pieces, rearrange those pieces to get a shape that you desire. Again, remember how I told you that we are going to try to approximate it to a rectangle. So right now it doesn't really look like a rectangle because it is slanted, and also the edges are curvy, the top and the bottom edges are curvy. So let's do one thing. Let's see what happens if we split this more than 8 parts. Okay, so let us take 12 parts this time. Why not? So we have 12, split them. I think the yellow color is really pretty, so I'll just color the alternate ones probably with orange. Okay. Coloring going on. Feel free to fast forward the video a little bit till you stop the coloring. Actually, feel free to go to mathigon.com and open Polypad. Create this on your own because you just saw all the steps how I'm doing this, and try to make a rectangle and see what happens when you go on increasing the number of parts. So you can pause the video right now and actually go to Polypad. You can see the link up there and do this by yourself. That would be a great exercise. Math is only learned by doing. Alright, I am gonna continue making this. You can pause my video and join me once you are also done making this. Polypad is so much fun. I love using it in my sessions. It's beautiful, it's very easy to understand. You can cut the shapes, split the shapes, there are pretty colors, and it's just lovely. Kids enjoy it. Okay, almost there. 4 more to go. Getting there, getting there, getting there. Okay, and we're here. Alright, so is this approximation better than the first approximation, or is it worse? So it looks like it's better than the first approximation. And it's still not a good rectangle, but if you can imagine breaking the circle into many parts, a lot of parts, and then rearranging them, then slowly you will start to get something that looks much closer to a rectangle. So the number of parts that you would split the circle, now this is supposed to be imagined, the number of parts that you can split a circle has to be infinitesimally small. The number of parts have to be infinitesimally small. The parts have to be the size of the parts. Yeah, the size of the parts has to be infinitely small. So when you rearrange them, they become so compact that it slowly looks like a rectangle. Okay. And once we're done with that, now there's a further procedure that we have to do. So if you look at this bottom, when it was part of a circle, covered circle, and it was the alternate ones, right? The alternate ones. So those alternate ones, if you group them together, then you would get half a circle. You would get half a circle. Now if you know the circumference of the circle, as we saw up there, it's 2 pi r, which means half of it is just pi r. So that means the length of this rectangle is pi r, and the width is this portion, at the portion that started from the center to the point on the circle, meaning the radius. And what do we do to find area of a rectangle? Length times width, and there we have it, pi r square. I hope you enjoyed it. And if you really like this video, then please let me know. I would love to make more videos for you. Thank you. Bye bye.